What does your body feel like in zero gravity?
What inspires you to become an astronaut?
What exercise do you do? And do you sweat in space?
Would a yo-yo work in microgravity?
So it works.
Station, this is Houston. Are you ready for the event?
International Space Station is ready for the event. Houston, how do you copy?
We read you loud and clear. Ready. Are you ready to start the event?
We are ready. Thank you.
Dakota State University. This is Mission Control, Houston. Please call station for a voice check.
Station, this is Dakota State University. Can you hear me?
Dakota State University, I hear you loud and clear. Welcome aboard the International Space Station.
Hello, station. We're speaking to you from the Beacom Institute of Technology at Dakota State University, Madison, South Dakota. In addition to DSU students, faculty, and staff, we're joined here on campus by nearly 100 8th grade students from Madison Central School District. The rest of the middle school students and several other regional classes will be joining us remotely. Today, we're celebrating Space Day 2018 at DSU. Our students are learning all about science and space-related topics with several presentations in addition to this interview. These include our partners at Raven Industries, Sanford Underground Research Laboratory, the U.S. Geological Survey's Hero Center, and South Dakota Public Broadcasting. I know the students are eager to ask some questions, so let's begin with our first special guest from the kindergarten class of Madison Elementary, Nolan Smith.
Hi, my name is Nolan and I'm in kindergarten. How long?
Hi.
How long is the mission in space?
And how long do you train for it?
And how long do you train for it?
Hi there, it's great to talk to you. I'm going to be in space for 197 days, for a little over a half a year, and most of us train for 2 to 2.5 years for a half-year mission to the ISS.
Hi, I'm Sam. How are your experiments different in microgravity than on Earth?
Well, that's one of the things we're here to find out. That is the variable we are able to offer here on the International Space Station, or one of the variables is a microgravity environment. So frequently what we are doing is comparing what happens up here to what we know to happen on Earth, and to see if there are benefits and detriments to certain things, like, for instance, human biology. What are some of the challenges the human body faces in a microgravity environment? And there's some things that do grow differently and react differently up here that might be beneficial to life on Earth. So those are the things we're really working on up here in this microgravity environment.
Are there themes for science experiments on each mission, and how are experiments chosen?
We don't necessarily have themes, but we have a broad category of experiments, and scientists around the world, over 100 countries, make proposals to conduct experiments on the International Space Station, and those proposals are vetted, and screened, and then they're prioritized for us to do them up here on the International Space Station. So based on that prioritization, they make their way up here, the hardware makes their way up here, and then we'll conduct the experiments for them.
How much privacy do you have on the space station?
I get asked that a lot, and you would think not very much, but there's 6 of us up here. We're on a vehicle about the size of a jumbo 747. We each have our own little sleeping quarters. So if you want privacy, you have your own small room to go to. That's about the size of a large refrigerator. But with the amount of space we have and people being respectful of each other, it's pretty easy to find privacy up here during the off hours.
Does spinning around in microgravity make you dizzy like it does on Earth?
That's the first time I've been asked that question. It seems to me that when you do spin, your inner ear's trying to figure out what's going on, and that's why you get the dizzy sensation. I don't think it's as drastic here on the space station as it is on Earth, and I think part of that is you're tumbling a lot up here, and your inner ear kind of adapts to it. But yeah, if you're spinning a lot, doing flips repeatedly, it'll take a little while for your inner ear to kind of stabilize, but I don't think it's as drastic as it is on Earth.
If you could have one more thing from Earth, what would it be?
Well, if it can't be a person, it would have to be a pizza.
What kinds of experiments are currently being done on the station, and what is your role in them?
We're up here conducting experiments for scientists around the world. Our role is to conduct them, follow the procedures, offer some advice on how to do things up here better, but ultimately it's the scientists on the ground who are in charge. Personally, I've been doing a couple of experiments that have been pretty exciting. I've been involved in plant growth experiments, both simple plants like algae and complex plants, vascular plants, which has been really exciting. And I've also been involved in an experiment where we are trying to identify the DNA in bacteria, which will have a benefit for us on the space station and when we go out into deep space. When we find bacteria growing, and that's one of the things that comes with us wherever we go, identification requires us to send it back to Earth. If we're able to do that here or on a lunar gateway or on the surface of another planet, it would save a lot of time and make us be able to help us identify things very quickly. That also has huge benefits, I think, to remote communities right home on planet Earth.
Does radiation affect your electronics or computers?
Yeah, it sure does. We're not that high off the surface of the Earth. We're only 240 miles, give or take. And so we're still within the magnetic field of the Earth. So we're protected from a lot of the radiation that we would get on a journey to the moon or Mars. But our computers still take a pretty good beating in a radiation environment. We also notice on cameras, when we take pictures, the video camera I'm using here, they pixelate a lot more quickly up here, being struck by subatomic particles and radiation. So yeah, it definitely is a difficult environment for complex equipment up here.
How do you shower and wash science equipment without gravity?
It's not the gravity so much that's the problem. It's the lack of running water. We don't use running water up here. Just the view you see, we have so much in the way of electronics equipment that we can't have water escaping because it's just too dangerous. So science equipment is meant to be used and disposed of. And for showering, we actually use towels that are impregnated with rinse-free soap and rinse-free soap, and we also use rinse-free shampoo. We can put hot water into a bag with the towel, take the towel out, wipe down really well, and use the shampoo in our hair, and it'll kind of dry. It's similar to the stuff we use when folks are hospitalized back on Earth.
We have heard that astronauts suffer muscle loss in space. What kind of exercise do you do to prevent this, and how does microgravity affect it?
Yeah, that's absolutely true. That's one of the things we learned early on, and particularly the large muscles like our legs just don't get used that much up here because we're floating all the time. And we're not standing, we're not walking, which are two forms of exercise you don't even realize you're getting on Earth. We are scheduled 2 hours a day, and you're absolutely right. How do you do the exercises we're used to in microgravity? We have a treadmill that we run on, or an exercise bicycle that we ride on every single day. The treadmill uses a harness to hold us down onto the active treadmill. The exercise bicycle, we can actually strap ourselves down to the exercise bicycle. Weightlifting's a little bit different too, because we can lift just about any weight up here. So we use resistive exercise. It's really just a complex, a simple machine, and kind of like Jaws that we stand in the middle of, and we can adjust the loads and do a lot of the major exercises that we would do in a gym back on Earth. And with that exercise, we have found people are coming home just as physically fit, if not more so, than prior to leaving Earth.
How do you grow plants in microgravity without soil and water getting everywhere?
It's a great question. That's one of the technologies we're working on, because we need to grow plants when we go out into the solar system. We're going to need them for food. They're going to help purify oxygen. We could use them in habitats in certain locations for both of those purposes. We have, part of that, we're testing what's happening to plants up here, and one of the things we're also figuring out is how to grow them. One of the plants actually uses pillows that are impregnated with moisture and the nutrients they need. We have another advanced plant habitat that I've been working on, where there's a reservoir in the water. It's all very controlled, pretty much soil-free. The important thing is nutrients and water.
How is air regulated and purified on the station?
We actually have two systems for that. We have a Russian system and the U.S. system, but both basically do the same thing. They provide oxygen. On the U.S. side, we generate most of our oxygen by splitting water, and that provides our oxygen. The water is purified we recycle up to 90% of the water here on the space station to use for oxygen generation and for drinking and for our systems. Those systems also help scrub and remove carbon dioxide, contaminants, maintain cabin flow, and even provide temperature and ventilation. So that's one of the systems that we've really figured out. We've really learned a lot up here. We have an amazing system that provides a safe atmosphere for us to breathe. And it's one of the things that's going to carry us out into the solar system, having that technology.
What foods do you miss most?
Yeah, I bet you're thinking pizza since I said that earlier. That's pretty high on the list. I'm from Maryland, so I missed the summer crab feasts and sitting around on a picnic table having crabs with friends and family. Also, fresh fruits and vegetables are a big thing. We don't get them up here that often. It's a vital part of our diet on Earth, and that's one of the things we're going to have to figure out for even longer stays in deep space.
Since the ISS orbits the Earth every 90 minutes, how does that affect your sleep patterns, and how do you adjust to it?
Yeah, great question, because going around every 90 minutes, we have 16 sunrises and sunsets a day. So if you spent your time looking out the window all the time, it would be very easy for you to lose track of when you're supposed to go to bed. The crew quarters that we have that I mentioned earlier don't have windows, so it's a nice, quiet, dark environment for sleep. And we stay anchored to pretty much to Greenwich Mean Time. So we have a set time where we start work every day and a set time where we end work. And that kind of drives bedtime and wake-up time. So just maintaining that schedule and not having the lights and the noise during sleep hours, and we're all kind of synced up, and it makes it quite easy.
Because of all the hazards of being in space, what kinds of fault tolerances and backup systems do you utilize aboard the station?
The space station is an amazing machine, and it was designed to safe itself. One of the big emergencies we're concerned about, for instance, is a fire. Well, the first response to a fire, unless it's an open cabin fire, is to really allow the system to safe itself. We have FITR, which is a fault detection identification response, which will actually, based on certain parameters, tell the space station what the hardware is supposed to do in the event of a parameter getting out of range. On top of that, we have a team of folks on the ground around the world, 24 hours a day, 365 days a year, also monitoring those parameters and making sure there's no trends that look like things are getting out of whack. And then we are obviously trained to respond to those particularly emergencies, the big 3 emergencies that we have up here, and also to help the ground once they figure out the station has gotten a safe configuration, the ground understands the problem, then we're trained to go fix it.
What inspired you to go to space?
Watching other people do it. I've always been interested in people who explore and stories of exploration, and watching people do this when I was your age and younger, it had a big impact. Like I hope Space Day will have an impact on you. This is a remarkable journey to be a part of, either here in space or being part of the team on the ground. And I strongly encourage you to be a part of that at some point in your career.
How is life aboard the space station different from an undersea lab like Aquarius?
You know, the schedule and a lot of it's very similar. That's one of the reasons we spend time undersea in the lab Aquarius off the coast of Florida. There's a lot of similarities in schedule and risks. One of the, I guess, the really big differences is we do spend a lot of time looking out the window in both. Here, we're looking down at our beautiful Earth. On Aquarius, we are looking out at the amazing life that is right there in front of us on Earth. But both of them really remind you of what an amazingly beautiful planet we live on, and just the complex systems that provide life, provide all that we need to carry on as humans on planet Earth.
What part of being in space is the most fun, and what part is the scariest for you?
Oh, the fun part is the people, both the crew I'm here with, the people on the ground, just being part of a team that's executing a really complex mission. That's really rewarding. Also, in my free time, looking out the window of places on Earth that I know I'll never get to, but at least I'll be able to see them from 240 miles away. It was, I don't know, today was, I think, the anniversary of one of the largest volcanic eruptions in at least modern history in the island of Indonesia. And we actually flew over Krakatoa today, or not Krakatoa, the volcanic crater that's still kind of active in near Indonesia. And just seeing those places on the planet and connecting them to points in history and thinking about, well, I've seen it, I might not ever get there, but it's fun to see.
How do you get up to the station and back down to Earth?
We all rode on a Russian Soyuz rocket from Kazakhstan. It's about an 8.5-minute ride to orbit, and it took us a couple days to get to the space station. And we will go back in a descent module from that rocket. And it's a wild ride. It's a capsule. It will land in the desert not too far from where we launched under parachutes. And I have never landed that way before. My previous mission was on a shuttle where we landed on a runway. But I hear it's quite a wild ride, and I get to experience it in a little over a month.
What do you do to relax and have fun on the station?
We I like to read. We have movie night every Saturday night. We like to look out the window. Sometimes we'll play games. I think we actually played the first tennis match ever in space about a week or two ago. Had to get creative how to play tennis on the space station, but we figured out it was kind of a combination of ping pong and tennis, but we'll call it a tennis match. But you know, just camaraderie and finding things to do, conversations, reading, and just hanging out together, just like you would do on Earth with your friends.
Do you have any animals on the station? If so, why are they there?
We do use animals. We have animals up here as part of science experiments. We sent home some bees not too long ago. None of them got loose, which was good. They didn't leave any honey behind, which was bad. We have some mice here with us now, and of course, as I told you earlier, we do have bacteria and mold and fungus, other things that have come up here. You can't keep anything, can't keep stuff sterile when you have humans involved. So we have our own little unique ecosystem up here as well.
Well, thank you, Astronaut Arnold, for all your hard work up there, and we wish you all the best success and a safe trip up there and a safe trip back.
Thank you so much. Happy Space Day. Appreciate you joining us and wish you all the best for the upcoming school year. Thank you so much.
Station, this is Houston ACR. That concludes the event.
Thank you to all participants from Dakota State University. Station, we are now resuming operational audio communications.